and in this video I'm going to walk you through setting up the AWS Storage Gateway. The Storage Gateway service connects on-prem software appliances with cloud storage, and the service offers file, volume, and tape-based gateway appliances and is a great utility for data migrations, backup, and archive. And so for this video, we're going to be working with the File Gateway. And the File Gateway is an on-prem virtual software appliance that runs as a VM on VMware ESXi and enables us to store and retrieve objects in Amazon S3 using standard file protocols such as NFS. So before we get started, let's take a look at a diagram that'll help illustrate what we will be deploying both on-prem and in AWS. In the top half of the diagram, we have our on-prem environment. And the File Gateway appliance requires VMware, Hyper-V, or to be deployed inside of EC2. And so for this video, I had to swap out VirtualBox for VMware Fusion. And VMware Fusion, unlike VirtualBox, lets us run VMware vSphere as a guest VM, which we can then use to host the Gateway VM appliance. The VMware ESXi host will have a bridged interface from VMware Fusion to our physical host's NIC, and this enables our File Gateway to easily communicate on the LAN in my office. And when nesting hypervisors like ESXi within Fusion, we need to make sure that we have enough resources to support the ESXi host and the Storage Gateway appliance running on the ESXi. And the Storage Gateway appliance requires 4 vCPU, 16 gig of RAM, and then an 80 gig volume for local storage for the gateway itself, and then a minimum of 150 gigabytes of cache storage. So on the bottom half of the diagram, this represents the AWS portion of the environment. And this has a single EC2 instance that we're going to set up inside the US West 2A availability zone. And we're going to place in an outside security group. And that outside security group is just going to let us SSH directly into that instance via the internet gateway so that we can access the EC2 instance directly from the on-prem workstation up there in the upper right. And then the File Gateway is going to communicate with the AWS Storage Gateway service for control and configuration, and then it's going to communicate with our S3 bucket for sending and receiving data. And the File Gateway, once set up and configured, is going to present our local workstation, represented by that icon in the top right, with an NFS mount, and we'll test sending files from our workstation to our EC2 instance and downloading to the EC2 instance's EBS-backed storage. So with that, let's get started. Okay, so here we are at the AWS console, and first we need to create a role. And this role is going to restrict access to our S3 bucket, and it's going to be assigned to our EC2 instance so that it can access the bucket that's going to be shared with our storage gateway for uploading and downloading files. So let's go to Identity and Access Management, and let's click on Roles. And let's go ahead and click Create Role. And then we're going to select EC2. This is the service that's going to be using this role, so we're going to click Next. And then we're going to go ahead and search for S3, and we're going to select Amazon S3 Full Access. We're going to hit Next, and we're going to call this S3 Full Access. And we're going to go ahead and click Create Role. All right, and the gateway is going to need a similar role, and when we set up the file share for our storage gateway, we will have the IAM role for the storage gateway created as part of the configuration of the share itself. Next, we need to create an S3 bucket to associate with our storage gateway's file share. When setting up the file gateway and the file share, the S3 bucket must already exist. So there's a one-to-one mapping between the file shares and the S3 buckets. So let's go ahead and set up our bucket. So let's navigate to S3. Okay, and the file gateway can have up to a maximum of 10 file shares. And in this case, we're just going to have one share and we're going to use one bucket. One thing to note is that the S3 bucket names are globally unique regardless of the region they're created. So it's a best practice to use a DNS style naming convention to ensure that your bucket names are unique. So let's go ahead and create our bucket, and let's click Create Bucket. And for the bucket name, we're going to go ahead and call it Tundra1-northlogic.net. and we're in the US West Oregon region, and we're going to go ahead and click Next. And we're not going to set any properties up, so we're going to go ahead and click Next. We're going to accept the defaults. And then we don't have any specific permission changes, so we're going to accept the defaults for the permissions. And then we're going to go ahead and review, and we're going to double check our bucket name is Tundra 1, and we're in the US West Oregon region, and we are not set to public. All right, let's go ahead and click Create Bucket. Next, let's take a look at security groups. Security groups are the virtual firewalls for AWS instances, and they're going to allow direct access from our on-prem workstation to our EC2 instance via the internet. So let's go ahead and click on Services. Now let's go ahead and select VPC. Then we'll go ahead and select Security Groups. And you can see our default security group here. We're going to go ahead and click Create Security Group. And then we're going to go ahead and give it a name, and we'll call this Outside. And we'll give it the same description. All right, and this is for our default VPC, so let's go ahead and click Yes, Create. And once that security group's created, we're going to go ahead and select it. And then we're going to go ahead and select Inbound Rules, and we're going to add a rule. So click Edit, and then we're going to select the type, and we're going to select SSH. And then for the source, we're going to enter in our public IP address. All right, we're going to go ahead and click Save. All right, so this is going to allow SSH inbound from the public IP address assigned to the office. Okay, we can now get started with setting up our EC2 instance. So let's go ahead and select EC2. And we'll go ahead and click Launch Instance. We're going to go ahead and select the Linux AMI. And we're going to select T2 Nano. And then we're going to click Next, Configure Instance Details. And we're going to select the US West 2A availability zone. And then we're going to select our S3 full access IAM role. All right, and then we're going to leave the rest default. And we're going to go ahead and click Add Storage. All right, and then we're going to accept the default storage for the 8 gig SSD, add tags. We're not going to add any tags, so we're going to click Configure Security Groups. And here we're going to select our existing security group that we just created. We're going to go ahead and select Outside. There you can see SSH22 will be allowed from our public IP. And then let's click Review and Launch. All right, everything looks good, so let's go ahead and click Launch. And here we'll select an existing key pair so that we can log into our instance. All right, and this can take a few minutes to create the instance, so I'm going to go ahead and pause the video to speed it up, and then we can log into the instance. Okay, with our EC2 instance running, let's go ahead and get the public IP address and log in. Let's go ahead and copy the public IP. All right, now that we're logged into our instance, let's make sure we can see our S3 bucket. And this will go ahead and list the S3 buckets, and there we can see tundra1-northlogic.net. Okay, with our EC2 instance set up and able to access our S3 bucket, we're now ready to set up the Storage Gateway service and our on-prem file gateway appliance. So let's go ahead and click on Services. And under Storage, let's go ahead and select Storage Gateway. And then we'll go ahead and click on Get Started. And then we're selecting File Gateway, so let's click Next. And then we're going to select VMware ESXi, and we're going to go ahead and click Download Image. And this download, the OVA image is about 800 megabytes, so it can take a few minutes to download, so I'm going to go ahead and pause the video to speed it up, and then we can continue setting up our gateway. Okay, with our image downloaded, we're going to continue setup of the file gateway from within our local on-prem ESXi environment. So let's go ahead and log into the VMware console. Okay, and from the VMware console, what we need to do is create and register a new virtual machine from the Storage Gateway OVA template. So let's go ahead and click Create Register. And let's deploy from our OVA file. Click Next. And then let's give this VM a name. And let's go ahead and select the OVA template that we downloaded for the storage gateway. And let's go ahead and click Next. And here we've got data store 1 with about 300 gigabytes of storage, which should be enough for the storage gateway. So we'll go ahead and click Next. And we'll go ahead and click Thick Provisioning, click Next. All right, let's go ahead and click Finish. And if everything's set correctly, the VM's going to power on, and when finished, we can go ahead and view the virtual machine. Okay, with our storage gateway virtual machine powered on, we need to add our cache storage and get the IP address. So let's take a look at our virtual machine. All right, so here we can see the Tundra virtual machine, which is our file gateway appliance. And the first thing we need to do is we need to add a hard disk to this virtual machine. So we're going to go ahead and click Add Hard Disk. We're going to add a new hard disk, and we're going to set that to the 150 gigabyte minimum for the storage gateway cache. We'll go ahead and click Save. Okay, and here we can see the second hard disk's been applied, and it's tundra1.vmdk. So that second disk is now attached to that virtual machine. So the next thing we need to do is go into the console and get the IP address. So let's go ahead and log in. All right, and here we can see our address has been assigned via DHCP, and it's 192.168.1.109. All right, so now that we have the address, we can go ahead and toggle back to the AWS console and finish registering our AWS gateway. Okay, with our file gateway set up in ESXi, we can finish setting up the storage gateway from the AWS console. So let's go ahead and click Next. All right, and here's where we're going to enter in the IP address that we got from the console of the file gateway. We're going to click Connect to Gateway. And then we're going to go ahead and select the time zone. So we're going to select Central Time. And then we're going to go ahead and give the gateway a name. And in this case, we're going to call it tundra-northlogic.net. All right, we're going to go ahead and click Activate Gateway. And our gateway is now active. And the next step is to configure the local disks. All right, and so no local disks are found. We just recently added that data store. We may actually need to reboot the file gateway in order for it to see these disks from the AWS console. So what I'm going to do now is go ahead and save, and then I'm going to pause the video, and we'll reboot that VM appliance, and then we'll log back in and continue the setup. Okay, and after rebooting our virtual machine within VMware and refreshing the disk in the AWS console, we're now able to see that we have 150 gigabyte, and that's that cache volume that we added to our virtual machine. So we're allocating that as cache for our file gateway, and we're going to go ahead and click Save and Continue. Okay, and now we have our storage gateway up and running and registered and configured, and we're ready to start setting up our file share. To set up our file share, we're just going to select our gateway, and then we're going to click Create File Share. And here we're just going to type the name of our bucket, and that's tundra1-northlogic.net. And we're going to go ahead and select Create New IAM Role, which will give the storage gateway access to the S3 bucket, and we're going to click Next. All right, and we're going to go ahead and click Review. And what it's alarming here is that we're allowing all clients to mount the NFS share that our local appliance is going to present. So we're going to go ahead and click Edit, and we're going to change this to 192.168.1.0/24, which will just restrict access to our local network. So we're going to go ahead and click Close, and that saves the allowed clients to our local network. And then we're going to go ahead and click Create File Share. All right, and that'll create the IAM policy, and it'll set up the NFS share on the local gateway. And next we'll go ahead and proceed with mounting the NFS share. Okay, to mount our NFS share, we're going to access the console of our local workstation. and then we're going to paste in the command. And this command is going to mount to a local directory, Tundra1. And we've given it the IP address of the storage gateway and the S3 bucket and that local directory. So let's go ahead and hit enter. Okay, and there the command's completed and we've created our NFS mount. So let's go ahead and display it from the file system and see what this looks like. Okay, and what I've just done here is just use the disk facility command. And an interesting observation is that the volume it's listing is its available capacity is 8 exabytes. That's exabytes. We skipped tera and peta and went straight to exabytes. So just for perspective, 1 exabyte is 1,000 petabytes or 1,000,000 terabytes. So the file system has to represent a figure, but in this case, the S3 backending our 150 gigabyte cache, we effectively have unlimited storage. Okay, next let's create a file in our NFS share that we can upload via the file gateway to our S3 bucket. So first let's go ahead and change the directory here. Okay, and let's just create a new file. Okay, and now we've created a hello world text file in the NFS share that our storage gateway will now automatically upload to our S3 bucket. Okay, and let's take a quick look at our S3 bucket from the AWS console. So let's go ahead and click on Services, and let's click on S3, and there we can see our bucket, and let's go ahead and click on our bucket, and there we can see our hello world text file's been uploaded by the storage gateway. Next, let's access the file from our EC2 instance and copy the file from our S3 bucket to our EBS storage, and that'll simulate our data migration to AWS. Let's go ahead and log into the console. Log into our EC2 instance. Okay, and let's go ahead and make a download directory. All right, and then let's go ahead and list the contents of our bucket. Okay, and there we can see our hello world text file. So now let's go ahead and download that file. And we'll download that to our download directory. All right, and there the file's been copied. And there we have our test file. Okay, so we've successfully uploaded a file from our on-prem workstation via our NFS mount to our local file gateway and transferred the file to our S3 bucket. And then we copied the file from our S3 bucket to our EC2 instance's local EBS storage. So the Storage Gateway service, it's a great utility for moving data in and out of AWS, and you can scale the service to really meet your read-write I/O or bandwidth requirements. And with the flexibility for file, block, and tape, with services like S3 and Glacier for scale and tiering, there's really many use cases where the Storage Gateway comes in handy. I hope you found this useful, and thanks for watching.